This is 3 steps to sketch for function transformations. And in this video, we're going to look at a transformation of the absolute value function. So we want to graph y equals negative absolute value of x minus 2 plus 5. And we will use the on the graph method. So here's our reminder of our graph and what method we're using, and our outline for 3 steps to sketch and a nice grid. So before we get started, let's go ahead and make ourselves a note that our parent function is the absolute value of x. And if you want to even, since we know we're going to do this on the graph, if you want to even just give yourself your 3 main parent points, so you have a starting point on the graph, that I think is something that's really nice. It gets you just set up and started right. Okay, let's go on to our 3 steps to sketch. Step 1, analyze transformations. We'll start with our horizontal transformation, and we know that horizontal transformations affect only the x coordinates, and they happen in with the x. So in this case, that's in the absolute value bars. And when we apply these, we should think about solving order. So all we need to do is take our horizontal transformation, set equal to 0, and that will tell us what we're actually doing to our x's. So if we were to solve the mini equation for x, we would do plus 2 to both sides. So this tells us we should be adding 2 to our x's, which shifts us right. So right 2 or x plus 2. All right, so that's our only horizontal transformation. Now let's move on to our vertical transformation, which these affect our y coordinates, and we should be applying them in PEMDAS order, and we do have multiple here, so that's really important. Okay, this negative out front you can think of as a -1, if that helps. Remember, negative signs will reflect, and so since this is a vertical reflection, it will reflect over the x-axis. It reflects vertically. And then this plus 5 is also a vertical transformation. It'll shift us up 5. Okay, and in PEMDAS, we know that we should apply multiplication before addition. Okay, so if you need to think of PEMDAS. All right, so first, we know we will reflect over the x-axis. That's like -1 times y, or just negative y. And then second, we'll move up 5, or y plus 5. Okay, so now we have all of our transformations, and we're ready to move to step 2, plot and transform. So before we started, we went ahead and plotted our parent points from the absolute value function, and now we can graph with intermediate graphs. Remember, different colors here can really help you out so you can keep each of your steps straight. We'll start by moving each of these green points to the right 2, applying our horizontal transformation. And I'll do this using a blue pen. Okay, so starting with the leftmost point, moving it right 2, okay, ends up at 1, 1. The point at the origin ends up at 2, 0. And our third and rightmost point, 1, 1, ends up now at 3, 1. So notice only the x coordinates change when you're applying a horizontal transformation. Okay, so take a second to switch colors. So we're now working from our blue graph, and we'll apply the first of our vertical transformations, and that's to reflect over the x-axis, or multiply all your y's times -1, if you would rather think about it that way. So our first point reflects over the x, or the y's multiplied by -1. The point on the x-axis just stays put, and our third and final point also reflects. Okay, so we've got that one done. And finally, we'll move now all of our yellow points up 5. So let's go ahead and switch to red as a final color. And we'll shift each of these points up 5. And we'll make these points dark because we know these points are for our finished graph. Notice that the x coordinates don't change. It's just the y coordinates here. So now we can sketch in our final graph. All right. And we have it. So this was graphing an absolute value function transformation using the on the graph method with 3 steps to sketch.